solution or liquid form. And not just being in liquid form, are they ionized? That is why even when you have the sample in liquid form, maybe like water, you still need to kind of digest with upper media, mix it with your HCl and nitric acid, mix the sample and still filter. The idea behind it is to ensure that everything is in the ionizable form. And because of the working principle of that instrument, it is highly dependent on the ionization state of that sample. So if you don't just ionize because it is water, you assume it's liquid, it's already in the form that the machine can work with, and you just subject it to that process, you might have one or two issues, because what you are actually looking for may not, some of them may not be in that form. And then sometimes you will have some organic phases within that same sample matrix. So the only thing that can help is when you digest. And when you carry out your digestion, you are handling the organic part of it. So all those other parts of it will trap some of those elements of the issues you are looking for will not be dissolved. And they cannot be ionizable, thereby increasing the sensitivity of that sample. So that when you subject it to the instrument, it can be detected on time, or it will not affect the accuracy of the result. So talking about chemical interferences, yes, I also talked about that one. So let's move to the next component. Now, detection limit. Detection limit is related to sensitivity. There's a relationship between them. But detection limit here is the lowest analyte concentration that can reliably distinguish from background noise. So that minimum concentration that the machine can detect, which can be distinguished from background noise. Normally, background noise is something that is inevitable when it comes to chemical analysis. But if you have the ability of that machine to kind of identify that concentration, reliably distinguishing it from that background noise, that is actually what the detection limit is. So then you know when the branch fine level of so here we say that at concentration associated, the analytical signal becomes comparable to random fluctuation. So that is why some instruments come, like the AAS, it comes with a deuterium lamp. Now the deuterium lamp there is there to